Okay, I keep looking up my nose, I realize. Sorry about that, I don't mean to. I should have this thing up here, but it's not as convenient for me to hold it that way. All right, so we're not talking about noses right now. We're gonna be talking about eyeballs, eyes. Look at what one of my students showed me, this cute little model here. We're here in lab, and this is from this guy right here. And what I found is, remember in lab we had said that we didn't have a model, that's what I told you anyway, a model that had the lacrimal glands or the lacrimal ducts on them. Well, look at this. The lacrimal glands are located in your eyelid, and you can see them on this model here. Now, and you notice here on the corner of the eye over here, that's the lacrimal duct. That's where it drains. So most people, but before you learned about the eye, and maybe before right now, most people would think that the tears, that's what we're talking about, the lacrimal duct. Most people would think that it comes out of the corner of your eye, right? No. The lacrimal gland is above your eye, and that's what we can see right here. And it's secreted from the eyelid onto the surface of your eye, and it drains to that little hole in the corner of your eye, which is where the lacrimal duct is, that orange part right there. All right. So in addition to that, I can't see so good now, but you can see I have eyebrows, eyelashes, eyelids, thank God. And we got all those extrinsic muscles that all of you are experts in right now. And the lacrimal glands, these are what we call accessory structures associated with vision. And so we had said with the eyelashes, the eyebrows, I don't really see them doing a whole lot to protect your eye, but certainly eyelashes are there to help prevent getting particles in your eye. And your extrinsic muscles of your eye move your eyes all over the place. And we had said that the lacrimal gland is going to be secreting a watery substance that has salts and mucus and lysozymes, digestive enzymes onto the surface of your eye. You know what else is there? When we talk about the lymphatic system, the immune system, we will talk about how you have a category of antibody, something called an IgA, immune globulin A. It's in your tears. What is it there for? To fight off infections. So the tears have a lot of functions to help. I mean, just think about it. We got this warm, moist environment that's just, do you ride a motorcycle? If you ride a motorcycle, you've got all this stuff coming into your eyes, unless you've got a full-face helmet. And so you've got bacteria and dust and everything, and you got to deal with it. So these accessory structures help deal with that. All right, so slide number 14, the eyeball. So we had said that we have you know about the sclera now, and you probably know about the cornea, right? It's on the outside. It's the clear. The cornea is the clear part of your eye, and the sclera is the whites of your eye. And the sclera and cornea are really tough. They're fibrous. Now, at least your sclera, because when you were cutting, you were like, wow, this is really tough when you were cutting open the eyeball. All right, so inside of that, though, we had said we had that Matryoshka doll, right? Layer upon layer, and you say there's another little one even inside of that, right? So as we move in, we go from the fibrous tunic, the sclera and the cornea, to the vascular tunic. That means blood vessels. And that choroid, that is a blood vessel-filled layer in there. And then we had the ciliary body. And now the ciliary body, you say, oh, wait a minute. I remember that ciliary body thing. It was connected to the iris. And it was in front of the lens, right? So when we have our eye, it was the lens, not in front of the lens. The lens was sitting on top, kind of pushed up against it, right? And so the lens is pushed up against this ciliary body, and what's going to happen is that we have the lens that's going to be there for focusing, and we have the iris. So let me restate that. The vascular tunic is going to consist of the choroid, the ciliary body, the lens, and the iris. Now, what does the ciliary body do? Remember, we have cavities. We have the cavity in the front, which is the anterior cavity, and here. And then behind it, we have the posterior cavity. Now, the anterior cavity, you didn't see a blob of goo, right? When you opened up the eye in the front, you didn't see anything. That's because it is filled with aqueous humor. Liquid, it's water. So when you opened up that eye, before you took out the blob of goo, which is the vitreous humor, which is in the posterior cavity, before you took it out, you probably saw a little bit of water in your pan, and that was the aqueous humor. Well, where did that come from? That is produced by the ciliary body. Have you ever, so it is produced by the ciliary body, and there is a condition that I'm sure everyone has heard of because it's not an uncommon condition. It is called glaucoma. And if I say, what is glaucoma? You'd say, oh, it's something to do with the eye. Oh, yeah, pressure in the eye, right? Well, it depends on however much of that aqueous humor you have. You're going to have higher or lower pressure in the eyeball. That's what they're measuring, is the pressure produced by that fluid, the aqueous humor, which is produced by the ciliary body. We have that hard ball that is normally clear in life, that is the lens, and we have the iris. And so the lens is going to focus the light that is coming in onto the back of your eye. After it passes through the vitreous humor, it's going to focus it onto your retina. Now, what about the iris? Sometimes, I'm in a room with a good bit of light right now, but if I was to turn the lights down, they have that sort of a scale type controller here in this room. If I was to turn the lights down, I'd still be able to see, and that's because the iris would open my pupil even more. So if you're in a dark room, your iris opens up to allow more light in. And if you're in a bright room, it closes it down to limit some of that light that is making its way in. Okay. So we've been talking about the anterior cavity. And that's that region there on the front part of your eye, in front of the ciliary body, right? And so in front of that, and we said it's fluid filled, and light is going to come through my glasses, through my pupil, through past the lens, which is clear, and it's going to be projected onto a spot in the back of my eye, a specific location on the retina. So we're going to go to slide number 15 now. And I want you to look carefully at this picture here. You see the light is coming up. So this is the front of the eye is down here, and laying in the back of the eye is back here. Back of the eye, front of the eye. And so we have this retina, that thin layer there, And in that thin foldable layer, we have layers, okay? So we're talking about the layers of that thin piece of tissue called the retina. Now, what did we say is the function of the retina? Photoreception. At the beginning of this talk, I looked at some receptors, and I said we have these two different kinds of photoreceptors, rods and cones. Rods are going to detect the presence of light only, and then the cones are going to be able to see those colors. And so they're in the retina, right? But that's not all that is there. We're going to talk about 3 layers from the front of the eye back. And the first thing you're going to have as you're moving towards the back is ganglions, not receptors. We have a ganglionic layer, and then we have a bipolar neuron layer. Oh, and then at the back, laying on the back of the most posterior layer in the retina, we have the rods and the cones. So what does the light have to do? The light has to come, squeeze past the ganglia, flow past the bipolar neurons, and activate either a rod or a cone cell. It's not the way, if you were an engineer and designing a retina, you would put the receptors first, and then the bipolar neuron, and then the ganglion, which would then send the signal to what? The optic nerve. But it's not designed by an engineer. It's not logical. This is the way it is, though. So we have these layers of that thin tissue called the retina. All right. So on that retina, here we have the posterior cavity right here, and we have the optic nerve, and we had said that we're going to have a certain spot, a certain location on the retina where when you're reading or doing something critical, where you're trying to really see something, what you're doing is you are focusing the image on a specific location. The fovea, the central fovea, that is the location where you are going to be having what we call critical vision. Your retina, your lens, and your eye changes, pulls on the lens, and you get everything focused on that one little spot there. This is where you're going to have most of the cone cells. The cone cells are what give you not only color vision, they give you critical vision, where you can see in great detail. Now, the other types of receptors, the rod cells, they just see light and dark. You see shades of gray. They're not present in the central fovea. But you have them all over the rest of this retina. You remember the retina is really big in there. And so you have a whole bunch of cones in this spot, and then the rods are spread throughout the rest of the retina. So what are they going to do? So it ends up, the rods are very effective in low light conditions, but they don't see anything in bright light. And guess what? The cones are very good in bright light, but they don't function very well in dark light. So if you're ever out walking through the woods at night, you're not seeing the bright, beautiful greens and shades of yellow and maybe reds because it's fall. You're not seeing any of that. You just see shadowy stuff. You see shadows because your cones aren't functional in those low light conditions, but your rods are. But you can't read without turning on a light. It's because the rods, there's a couple of reasons, but they're not present in the central fovea. Plus, there's another reason that I'll talk about here in a minute. You don't have the visual acuity that you have with the cone cells. All right, I'm going to stop right here, and we're going to come back and talk more about the retina. I'm at 15 minutes. I better stop.